Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about future of our transportation. So let's dive right into it. Well, let's look at something that is very close to our homes, cars. Now, cars are switching to electric. That is already happening. It's done deal at this point in time. This is the way of future. There won't be anything other than this. So flat out it's taken care of. Now, why people are switching at this point in time? The primary reason is cost of ownership is coming down. What does that translate to? That simply translates to, if you're not an individual who's gonna buy a car and gonna switch it, resell it every few years, you may be like those kind of individuals, like I'm gonna buy a car and then I'm gonna use it as long as I can. In those sort of scenario, having an electric car simply flat out is cheaper to own. So in those sort of scenario, even with higher capital cost, people are willingly buying this. And I'm talking about India also. Mahindra E2O is already selling a lot. Tata has already introduced a new system. So lot of success is here, and it's gonna happen sooner or later. It's gonna happen. There is no hydrogen here, there is no this or that. Flat out electric system is taken care of. It's just how long before every car is turned to electric system. So we have to expect some delay. Now why there is delay? Simple. Capital cost is too goddamn high. These cars, while in terms of their performance, they're not as good as like their cost. So if this car costs, let's say 5 to 10 lakhs, it does not have the performance that matches 5 or 10 lakh rupees petrol car at this point in time. So people are not going. And not to mention, if it was priced more competitively equivalent to its performance, people would be very happy to buy this. So right now price is the main issue. Then we come to another aspect that is a bit bigger, that is trucks. Now trucks are primary movers from a main factory point to your location or the groceries chain near you or shopping mall near you. So they are very slow to change. The primary reason, they are a business. Every vehicle they buy is generally being used to the last maximum. They are not buying trucks where like, oh, I'm gonna buy this truck and I'm gonna use this for 1 year, then gonna sell it out. They never do that. They buy it until everything starts to fall apart. They will try to utilize it as far as possible. So changes in that kind of industry takes very long amount of time. So you have to be a bit patient with that. Now at this point in time, there are two primary alternatives that people are trying to develop. One is electric system, basically electric cars on steroids, and then you have hydrogen based system. Now you may be like, why hydrogen randomly? If hydrogen has already proven a failure in vehicle system, why the heck you want to introduce it to the truck? Well, primary reason, range. So can you make an electric truck that is powerful enough to carry heavy loads? Easily. Here's the problem: it can't carry heavy load simply because each road almost everywhere in the planet has regulation how heavy your truck can be. If you design a truck that can carry the maximum load is required to, the batteries required to carry that load would be too goddamn heavy, so total weight would be too damn high. And because of the wheels regulations and all that jazz, there is a limit how heavy per wheel can be. So these trucks have serious limitations. So how much weight they can haul, that's not good. On top of that, it does not get lighter as charges are being used up. That is a very significant advantage of hydrogen, and on top of that, hydrogen is very light. So practically speaking, the fact that you can refuel this puppy up very quickly, which makes them time sensitive environments much more quicker, because again, they are making money as long as they are moving. So they cannot afford the luxury of, hey, I'm gonna plug it into a charge system and wait overnight. That's not a desirable outcome. And especially if they are maintaining fleet, they could have a drivers that swap out and trucks keep going on. So in those sort of scenario, flat out hydrogen is much better system. Now why hydrogen is not winning out if it's clearly superior here? Well, because of the infrastructure problem. EV, while with all the hurdles and weight limitations and all that jazz, they are still easy to charge. Like you can go to a petrol pump, just charge it right there. You can't go to a petrol pump that has a freaking hydrogen right now, flat out. And making the hydrogen fuel stations, that is not cheap investment. You're talking millions to billions of dollars in investment, and nobody's gonna buy a hydrogen truck unless there is a fuel station, and nobody's gonna build a fuel station unless there are trucks demanding it. So that's a likelihood of hydrogen trucks taking over is very low, but still making a good fight. So at this point in time, because of our current technological limitation, there is no viable alternative. Like you might expect to see basically diesel powered trucks for a few years or even decades at this point in time. Do not expect it to change. I can easily guarantee you that in next 10 years you will see more and more electric cars where you live, but I can't guarantee that with the trucks. They have still a long way to improve. What about trains? Now trains, ironically, we have already taken care of. Even though they move a large amount of people, we are already utilizing electric trains most of the places. Even India's trains are mostly electric. So flat out trains has been taken care of, and all we have to do at this point in time to reduce their carbon footprint is make the grid itself green. In which scenario, India is pumping a lot of money into solar systems. So solar systems are already coming online, wind systems and other technologies that we are trying to utilize, which overall sooner or later will make our grid itself green. Once the green grid becomes the green, these things inherently become green. So in terms of train itself, right now Indian Railway, while we have a lot of power, we have a lot of capacity, we do not have a lot of efficiency. So basically trains have to change their architecture. So they have to go from making primarily made out of steel to primarily made out of aluminum. So they become lighter and more efficient. So we still have a lot of building technology that we have to improve. Basically the core structure have to be improved in order for trains to become far more financially viable and less carbon footprint. So very little improvement. It's like it's gonna happen slowly, and you will not notice any change. Now, aircraft, well, let me be very clear. Flat out, there is no way to change a jumbo jet. The way that we have jumbo jets, the big jet engine systems, flat out, they are the most efficient at this point in time, and we're not going to change it. No matter what you do, there is no financial reason to change it. So at this point in time, the only thing that can be changed is the fuel. So in this category, we can basically replace the jet fuel from LG biofuel. And the primary reason why you want to do it this way rather than develop a new technology is simple, because it will work without changing current aircraft. Basically, you can go to Boeing and be like, Boeing, sell me a plane. Boeing is like, here's your plane. And you're like, okay, here's a biodiesel, it's gonna work. You don't have to think about it. And if it's not working, that means your biodiesel is not pure enough or filtered enough or matching the specification required. So if it matches the specification, it's gonna burn without any issue. Military have tested this puppy with their basically fuel systems, fighter jets, and it still works. So you don't have to worry about it. So United has already tested Eco Skies, where they use the jumbo jet with biofuel. India has already tried with Spice Jet, going the green mile. And so in this sort of way, slowly the fuel source will change, but it will take time, because biofuel, while on paper does make sense, financially they do not. So jet fuel prices have to go up a lot before people realize, you know what, switching to biofuel is far more financially viable. So do not expect any change in big jumbo jets anytime soon. Some experiments will happen, and more experiments will happen, and then you might find, hey, this airlines is utilizing biofuel extensively, but don't expect any major change anytime soon. However, there is a small market of electric aircrafts. Now, these aircrafts, they are not big, they are not powerful, they are not long range, nor they are very fast. But they are selling off the, they are going off the shelves without any issue. Why? Because people love them. Why? Think of it this way. What's the first aircraft, pilot learns? Training aircrafts. Training aircrafts are not designed to, being flown for a very long amount of time. Training aircrafts are generally tested in small airfields, and they have a lot of people living around them. They are not exclusion zones. So in those sort of scenario, having a plane that makes a lot of noise is very bad. Having a plane that consumes a lot of fuel, that's also very bad, because aviation fuel is expensive as hell. It's not like your gas you put in your car. It's expensive as hell. In those sort of scenario, people want to have something that is much more financially viable. Electric aircraft solves this issue simply because even though this puppy will not last more than 30 minutes in the skies, that's more than enough for one training session. And if you all you have to do is just take the plane, take to the skies, train the pilot, then come back, replace the battery. Some systems have where you can just swap the battery, which allows you quick turnaround. Some systems have where you charge the battery, so depending on what you want, and you can just keep doing this, and you do not have to basically have a fuel supply, fuel depot, fuel management system. These things are expensive as hell, specifically when you're dealing with jet fuels. So these things are becoming far more attractive as a training vehicle, and a lot of people are pouring their money into this, because this is something that is there is an actual reason to utilize this. It's like a right tool for the right job, well suited. Now, if electric aircraft, some companies are trying to design medium range aircraft, basically 200 kilometers to around 500-kilometer range. Now, if that happens, I can see a lot of smaller air runways becoming far more utilized. For example, there is a runway in basically Calcutta International Airport. So you can come to Calcutta from anywhere on the planet. Okay, awesome, everything is fine and dandy. But to reach to, let's say, my hometown from there, there is a small runway. Now, it's not an international system. Either you can board another big plane and then come here. Then the problem is with big planes is you need a lot of customer. Smaller planes fit that role. It's I do not need, let's say, 10 passenger. It could work as low as 6 passengers. In those sort of scenario, having an electric system would be far more financially viable, because electricity is cheap compared to jet fuel, and you do not need to have a fueling system in a remote area. Power systems are far more easily deployable. So flat out, there's a lot of potential in electric system, and training aircraft, they are already going off the shelf. And if somebody makes 4-seater or 6-seater EV systems for medium range, I can see a lot of demand for those things. But never even think about jumbo jets of long range flight. Don't even think about it. Not even with solar. Don't even think about it. Another aspect that is recently in the news a lot, shipping industry, simply because Suez canals got jammed, and every Tom, Dick and Harry is whoa, shipping is very important to humanity. So right now nuclear tech is almost ready for a marine environment. The reason why I'm saying nuclear technology is ready for marine environment, we have been utilizing this for long enough. Like nuclear reactors, small, powerful, capable, safe nuclear reactors have been tested in aircraft carrier, submarines, all sort of military vehicle, including icebreakers and cargo carriers. This is an actual cargo ship that utilizes a nuclear power plant to run. So we have basically enough experience where they can like, no, if you're building this is gonna be safe, this is gonna last long enough time, and it's gonna be financially viable, because the crude oil prices are going up. They're slowly creeping up, and this is not refined fuel. They run on what we call heavy engine oil, so they are not very refined nor very expensive, because again these puppies consume tons of fuel per hour. So in those sort of scenario, the fuel cost is not that kind of thing, but consumption is. So what does that translate? That translates to simply because you have to run your ship at slow speed. So there is a speed, basically you run it slower, it consumes less fuel, but you take longer time. So longer time you take, the less you have to pay your crew, everything else, so price goes up. So there is a balancing act, how fast you can drive these things while still getting maximizing the profit. But if we replace these systems with basically flat out replace this puppy with let's say nuclear power plant, we save so much basically cargo space. Like basically there will be a huge cargo space left, simply because we do not have giant fuel tanks. These fuel tanks on cargo ships are enormously huge. So if you don't have giant fuel tanks, those will become usable for container ships. So that's another advantage. Another aspect is you don't have to think about fueling it for 5-6 years minimum, and that's if you are burning it 24/7 into 365, which you can do with this sort of system. So that's why there is a lot of potential of small modular reactor taking care of these things, and we have enough experience. But right now the prices are slowly creeping up. So, and small modular reactor is already reaching a maturity point. So there is a crossover point. The moment that crossover happens, I can easily see shipping industry slowly without anybody noticing. It's like, hey, oh, that's a nuclear one, oh, that's another nuclear one, oh, all of them are nuclear, nobody would even notice it. So I can see a lot of potential to make these industry green. That's the most viable solution that we can deploy today, not something like over 10 years from now or 100 years from now, today. So this was my presentation on our overall picture of transportation industry. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.